All right, you guys, we're going to be going over some of the summer assignment problems to give you guys a little bit of review uh, before the test. So here we go. So the first couple problems is more just checking that you can plug stuff into a calculator right, and also that we can figure out units to get. So 1/2 mv squared, 1/2 times 210 is 100. Oh, let's go down to there. Okay, 105 kilograms. And then 10.5 meters per second quantity squared is going to give us 110.25, and then all the meters and the seconds are squared, everything in there. So the meters and the seconds. So meters squared over seconds squared. And all of that ends up giving us 11,576.25 kilograms times meters squared over seconds squared. So our final answer would look like that. Okay? Now, for the next one, just kind of an example problem, here we have some inverse stuff going on. We have 1 over a quantity. And you'll see this later in the year, and this is for parallel resistors. But just to do the math, we want to solve for that variable r sub p. So our final answer should look like rp equals and then something. Okay, so we got to figure out what that is. So as of right now, if you were going to plug this into a calculator, in your calculator you could put brackets 1 divided by 24 plus brackets 1 divided by 18 and see what that gives you. And what we would end up with is 1 over rp is equal to 0.972 0.0972, and then our units would be over, and then the ohms, that little symbol is still on the bottom. Okay. Now we want, like right now our answer is 1 over rp. We want to just get rp equals. So all you do is we're going to take the inverse of that, meaning we just 1 divided by all that stuff. So take the inverse of the left side of that equation, and we have rp. And taking the inverse of the right side, so 1 divided by 0.0972, and we would have 10.29, and instead of 1 over ohms now, flip it upside down, and now we just have ohms. Okay, so our final answer would look like that. So that's for the kind of plug and chug stuff, and really it's working on getting units. Now for this is a big deal for the AP Physics 1 and just general problem solving. We want to solve for a specific variable. So no numbers, no anything, just get the variable alone. And so for this one we want to solve for h. So right now I have u sub g equals mgh. And I want to get that h alone. So first thing I need to do is get everything to the other side. All of these pieces are being multiplied together. So I'm going to do the opposite. And I'm going to divide. So if I divide, just zoomed in so I can go a little finer. If I divide both sides by m times g, then let's get right there. M's cancel, G's cancel, and what I'm left with is U sub G over mg is equal to h. And there's my final answer right there for h. Okay. Now, a little different. We want to solve this for Q2. So Q2, just like, again, we want to get it all alone, so first thing I'm going to deal with is get that denominator away, so that r squared. And to get a denominator to go away, because it's being divided, I'm going to multiply. So I'm going to multiply both sides by r squared so that these cancel. And I end up with f r squared on the left, and now on the right hand side I have k times q1. And now we're kind of back to the previous problem. I need to get q1 times q2. Yep. Now I need to get that q2 alone. So all of these are being multiplied. I can divide by everything that I do not want. So the k and the q1, all those cancel. And what I'm left with is f times r squared divided by k times q1 is equal to q2. And there's our final answer for q2. So next we have a problem, a little bit different, kind of, if you haven't noticed yet, this is just kind of testing all of your algebra skills. But next we want to get this final position, or x final, all by itself. So I need to get all of the pieces to the other side in order to do that. So this one's a little different because now we have pieces that are being added and subtracted. So all of the added pieces, I'm going to move over to the other side first. So first thing I'm going to do is I'm going to subtract v initial squared from both sides. Those cancel. And what I'm left with right now is vf squared minus vi squared equals negative 2a times xf minus x initial. Okay, now really I'm back to our first problem where all of this stuff is being multiplied now, or the parentheses are being multiplied. So I need to get that piece outside of my parentheses to go away. So I'm going to divide, let's use blue, I'm going to divide both sides by what I want to go away. So negative 2a, it's being multiplied, so I'm going to divide it to get it to move over. And I have to divide the entire left side by that negative 2a. Now those cancel. And what I'm left with now is v final squared minus v initial squared, all divided by negative 2a is equal to x final minus x initial. And I'm trying to solve for that x final. So the last step here is that minus x initial piece on the right hand side. I'm going to add that to both sides. So plus x initial and plus x initial to both sides. Those cancel. And then I have v final squared minus v initial squared, all divided by negative 2a, and then plus x final. X initial. Notice I cannot put it in that little expression I have already on that side because it does not have a common denominator. So I can't combine those two expressions. And that is all equal to x final. So that right there is our final expression for x final. Okay. Ooh, now we get to some angle stuff. And angle stuff is really more like puzzles. So for the angle stuff, we want to always kind of see what we have. So there's some important pieces that are given to us here. First of all, that dotted line that you see, See how that dotted line goes right through it, and it tells us this is a right angle, right? So if that's an important piece, because now this whole thing, if that's a right angle, then that means this has to be a right angle, which means this has to be a right angle. So all of these pieces are all these little corners are 90 degrees. Okay, and that's going to play into kind of help us out along the way. So we want to figure out actually what's going on here. So if theta is 37 degrees, and this is a right angle, which means it's 90. Okay? And I know that all angles in a triangle have to add up to 180 degrees, all the interior angles of a triangle. So if I have 30, 37, and 90, that's 127 degrees. What do I have left? This little piece in here is 53 degrees. Okay, now that's not any of my answers yet, but I can figure out the rest of that stuff. Because if you remember, what did this need to be? This corner needed to be 90 degrees. Well, if 53 of those degrees are already taken up, then I know D is going to be 27 degrees to make 90. Okay? So D is 27. Well, if D is 27 degrees, here's the beautiful thing. If you remember back to geometry, what do those guys look like? Alternate interior angles. So if D is 27 degrees, that means A is also 27 degrees. All right? Now, if A is 27 degrees, and we know, so if A is 27, and this, remember these corners going on, all of these need to be 90 degree angles. Well, if A is 27, that means that B has to be 53 degrees to make 90. And then the last thing right there, probably could have put lights turned off. There we go. Oh yeah, probably could have put this one first, but that C angle right there is going to be 90 degrees. Okay? Makes a right angle right there. There's nothing there taking up any of the 90 degree angle. So all of our answers are right there. And it's literally just kind of putting the pieces around and seeing what makes everything add up to follow the rules. Okay? I'm going to give you the really quick rundown of a lot of stuff. But the general kind of saying a lot of people always use to memorize this stuff is so katoa. So ka toa. And all of this stands for certain stuff. So is sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And TOA is tangent is equal to opposite over adjacent. Now, if you don't remember trig, right now you're going, well, what the heck is adjacent, hypotenuse, and all that stuff? And that one's pretty simple. It's you have to have a right triangle. So none of those are right triangles, so we'll draw it. If I have a right triangle, which means that corner has to be 90 degrees, Okay, the easiest one to remember is the hypotenuse, because there's two rules about the hypotenuse. The hypotenuse is always the longest leg of the triangle, and the hypotenuse is also going to be across the triangle from the 90-degree angle. So if you just kind of find this 90-degree angle right here and go across the triangle from it, that's my hypotenuse. Okay, so that one's pretty easy. The other two, adjacent and opposite, all depend on where your angle is, what angle you're looking at. So let's say theta is up here. Let's say it's in the top. Well, if I'm going across the triangle, if I'm using the triangle to figure stuff out, opposite the triangle from that angle would be right there. And adjacent is just a fancy way to say next to. So my adjacent side is the side of the triangle that is next to the angle that I'm looking at. So my adjacent would be right there. Okay? And so I'm going to figure out all of these things by using these little sayings and this setup of a triangle. So to show that stuff in motion now, we'll look at our problem. So solve for the missing side. So right now we have theta is equal to 30 degrees. So there's my angle. So the easiest way to go about this is label them real quick. Okay? Opposite of my angle is the y. Adjacent to my angle is the x. And here's my 90, right, the corner. So what I'm given is the hypotenuse. Okay? So if I want to, what am I given right now? I know the angle, I know the hypotenuse, I want to figure out the other two missing pieces. So let's use, if I want to figure out y first, right there. That is the opposite side. So I want to use opposite of my angle. So I'm going to say sine of my angle theta is equal to opposite over hypotenuse. Okay? Now it just becomes plug and chug. Sine of 30 degrees is equal to my opposite side, which is called y in this problem, and my hypotenuse, which is 12 meters. And now it's just an algebra problem. Now I literally just have to solve it for y. Y is being divided by 12, so to get y alone, I'm going to multiply both sides by 12 meters. 12s cancel, and what I am left with is, let's see, 6. And because all of these legs are representing lengths, because they're in meters, my answer is going to be 6 meters. So there's y, and we're going to do the adjacent side, x, in the exact same type of process. Okay, but now I have the adjacent side. So I have adjacent, I have my hypotenuse already that was given to me. Adjacent and hypotenuse. The only one of these sayings out of SOHCAHTOA that has adjacent and hypotenuse in it is cosine. So I'm going to use the cosine of my angle. So cosine of theta, let's make that a little bigger. Is equal to adjacent over hypotenuse. Okay? Now plug and chug. Cosine of 30 degrees is equal to adjacent, which is x, over my hypotenuse, which is 12 meters. We want to solve for x, so we're going to multiply both sides by 12 meters. Those cancel, and I'm left with an answer of x is equal to either 6 radical 3 meters if you're being like that. In physics, we're usually going to use decimals. So if you turn this into a full-on decimal, we have that rounds out to about 10.4 meters. Okay? So all this is solving for those two sides using trigonometry. All right. Same process, we're just given different pieces. So a little bit different part of the puzzle. We do not have the angle. Okay? We do not have the hypotenuse, but we do have two legs. What we have is the opposite side and the adjacent side. Okay? So, if I have opposite and adjacent, O and A, the only one of my SOHCAHTOAs that work with that is the bottom one, tangent. Tangent uses both opposite and adjacent. So let's set that up. Tangent of theta is equal to opposite over adjacent. Okay, now plug in all the things we know. Tangent of theta is equal to 15.1 meters divided by 4.3 meters. Take a look what happens to the units too. Right now I have meters in the numerator and the denominator. Those cancel each other out. So I have no more units. The next piece is getting theta alone. So there's a trick. That tangent theta, the tangent part needs to go away, so we just have theta left. Right? So to do that, we use what's called an inverse function. So I'm going to take inverse tangent or arctangent, whatever you want to call it. So I'm going to take inverse tangent, and whatever I do to one side, I have to do to both sides. This is literally just something you can plug into your calculator. Okay? Well, what happens? Inverse tangent and tangent cancel each other out, so I'm left with theta equals the inverse tangent of 15.1 divided by 4.3, which when you plug that into a calculator ends up being right about 74.1 degrees. Okay, so there is our angle right there that's given to us. To find what D is, that hypotenuse, there's a whole bunch of different ways. You could use trig if you want. You can do anything. You know what we also do? We have a right triangle right now with two legs. We want to find the third. So you could use trig, but probably the most straightforward, simple way to do it is Pythagorean theorem. If you remember Pythagorean theorem, both the small legs, the square of both small legs added together will equal the square of my hypotenuse. A squared plus B squared equals C squared. So we're trying to get what the hypotenuse is. So basically 15.1 squared plus 4.3 squared equals, in this case it's called D. D squared. Solve for D. So we would square root both sides. To give us an approximate answer of right around 15.7 meters. All right? Unit conversions. So unit conversions are, again, another thing we'll do a lot of, and not too bad once you just know the process. Here we want to turn 35 kilograms into grams. So you're going to start with whatever you're given, 35 kilograms. And the easiest way, the way I think a lot of you guys at Sunny Slope were taught in chemistry, is this little kind of box method. We call this dimensional analysis. So if I want kilograms to go away and it's starting on the top, I need to put kilograms on the bottom to get it to cancel. So for every 1 kilogram, there are 1,000 grams. Okay? And that is all I need for that. And so what happens now is kilograms, you see we got kilograms on top and the bottom, those are going to cancel each other out, and what I'm left with is just grams. So 35 times 1,000 is equal to 35,000 grams, or if we wanted to put it in scientific notation, 3.5 times 10 to the 4th grams. Okay, so pretty straightforward, not too bad. The next one's going to be a little more complicated, but you'll see it's literally the exact same process. Okay, so I start with 31 kilometers per hour. And what's going to happen is a lot of people see this and they get weirded out. Okay, but what does 31 kilometers per hour tell me? That means that I go 31 kilometers for every 1 hour. Okay, so if I start it like that, that's an easy way to get going. So, just attack it in pieces. Let's do kilometers first. I want to turn kilometers into meters. So kilometers is on top. My conversion, I'll put kilometers on the bottom. So for every 1 kilometer, there are 1,000 meters. Okay, let's see where we're at. Kilometers cancel. I'm left with meters. So my distance units are good. I got meters in the numerator. Okay, let's look at the hours now. Okay, my hour is on the bottom. So to get the hours to cancel out, I need to put the conversion hour on top. So for every 1 hour, let's get this a little bigger. For every 1 hour, there are 60 minutes. Easy enough. Okay, let's see where we're at. Hours cancel. So right now I have minutes in the bottom, but I want seconds. So I have to go one step further. And I just repeat the process. For every 1 minute, there are 60 seconds. Okay? My minutes cancel, and I'm left with seconds. So right now I have meters in the numerator, seconds in the denominator. So this is exactly where I want to be. And now it becomes just simplifying that math and plugging everything into the calculator. Okay? So 31 times 1,000 on top is 31,000 meters. Divided by, on the bottom, 60 times 60, 3,600 seconds. And when we simplify that fraction, we get about, where is it? 8.61 meters per second. Okay? So same process, just a few more steps. So for vectors, we're going to use the tip-to-tail method. And you'll kind of see what I'm talking about with that. So vector arithmetic, or vector math, is the following. If I have here x plus y, and these are my two vectors, then I'm going to put those two vectors together using the tip-to-tail method. So this is all qualitative. There's not numbers involved yet or anything like that. So my x, I start there, and so I'm starting right here. So there's my x. When I add my y, I put tip to tail. I'm going to put the tip of my x to the tail of my y. So I start the y right at the tip of the x arrow. And the y one looked kind of like that. Okay. The resultant vector is after we've done tip to tail with everything involved, we figure out, I start at the beginning of my first tail, the x, and I draw a line to the tip of my last arrow. So that right there is what we call the resultant vector. Okay? So that is the resultant, that red arrow right there. For our next example, C minus D, the minus sign, all the minus sign changes is we do the opposite. So tip to tail still works. We start with C. Okay, so this thing, we have C going down. But minus D means we're going to do the opposite of what it says. Originally in this it says D is going to the left. So minus D means that we do tip to tail, but the D is going to the right. So when I draw my resultant vector, I start at the beginning and I draw a line going to the end. That's my resultant right there. Okay? So this is all the qualitative ways we can do it, just really kind of to get an overall feel for what's going on. If we want to get a little more mathy with it, a little more quantitative, we can put actual numbers to it. So same exact stuff is going to go on right now. We are going to use the tip to tail method, but we're going to actually have some numbers involved. So if I have, think about a coordinate system, right? If I have a coordinate system, or coordinate axes, I got positive x's going this way, positive y's going up, negative x's to the left, and then negative y's going down. We're going to use that exact same thought process when we're doing all of our vector stuff. So if I have x is positive 200, okay, that means I have, it's a terrible line, I have an arrow going to the right in the positive x direction that is 200 long. And then I have y in the positive 100 direction. So that means tip to tail, I have an arrow going up in the positive y direction that is 100 long. And notice I made these relative to each other. So roughly, the 200 is twice as big as 100, right? So the 200 vector should be twice as long as the 100 vector. And then we are being tasked with finding the resultant. So the resultant is figuring out what is that vector right there. Now what this should look like is a right triangle. And we have tons of wonderful ways of finding all the missing sides and angles and everything of a right triangle. So right there I have two legs. So the easiest way to find a resultant is probably Pythagorean theorem. So remember, a squared plus b squared equals c squared, or 100 squared plus 200 squared equals the resultant squared. And solving for that, we would get that the resultant is about 224. Okay, there's no units involved with this, so just 224. So that right there is the length of my resultant. Now, if I wanted to find the direction, or what we call the direction, that would be the angle of that triangle right there. The angle that it goes up from the x-axis. So to do that, I can set up trig, right? I have the opposite and adjacent side, so the easiest way to do this is use tangent. So tangent of theta is opposite over adjacent. Now plug and chug. Theta is equal to the inverse tangent. Opposite is 100 over adjacent is 200. And that comes out to be right around 26.6 degrees. Okay? So my resultant is 224 long at an angle of 26.6 degrees. Now, for the last example, we set this up. Remember, I got positive x, positive y, negative x, negative y, right? Because that's actually going to play a little more important role in this one. So for the x direction, I have positive 30. So remember, we're doing tip to tail. So I go positive, let's do it in red, positive 30. And then minus 60, we're going in the minus y direction now. So that means I'm going down 60. So down 60. Okay? And again, relative lengths. So the 60 arrow should be about double the length of the 30 arrow. And we want to find the resultant. So we start where we started and draw an arrow to the tip of the last arrow. And that's the resultant that we want to find. Okay? So use Pythagorean theorem. R squared equals 30 squared plus 60 squared. So my resultant is about 67. Again, no units. And then if I want to find this angle right there, then my theta is going to be the inverse tangent of opposite over adjacent, so 60 over 30, which comes out to be right around 63.4 degrees. All right? So hopefully this helps you guys out a little bit. You can take a look whenever you want and come in before and after class and we can talk a little more. All right? Thank you.